All right, welcome back. This is part two now. And epidemiologic studies on the effects of environmental factors often deal with very specific factors that can be measured quantitatively. Exposure and dose are particularly important in environmental and occupational epidemiology. Exposure has two dimensions, level and duration. For environmental factors that cause acute effects more or less immediately after exposure starts, the current exposure level determines whether effects occur. For instance, the London smog epidemic of deaths from lung and heart disease is shown in the next slide in figure 9.2. It's one of the world's first major environmental disease outbreaks that was documented in detail. So here we see the London smog epidemic, December of 1952. And in it, we can see where they're charting then um, increasing numbers of deaths related to rises in smoke and SO2 parts per million there. However, one issue is that many environmental factors produce effects only after a long period of exposure. For example, chemicals that build in the body or hazards that have an accumulative effect. For example, radiation exposure or noise exposure. Or things that have an accumulative effect, the past exposure levels and the exposure duration are more important than one's current exposure level. The total exposure, or external dose, needs to be estimated. It is often approximated as a product of the exposure duration and the exposure level. So, for example, does one have an increased risk of cancer after only one X-ray? Or does it require multiple doses? Figure 9.3 illustrates how the exposure increases, or how it illustrates how the exposure increases. Increasing the exposure increases the relative risk of lung cancer in this case. Here's a relationship between asbestos exposure in particle years and the relative risk of cancer. So, exposure, particles per cubic foot by years. If there is very low levels of exposure, as measured in this per cubic foot by years, then the relative risk of lung cancer is very low. But as that exposure increases, then we see an increased risk over time. Sometimes a proxy measure of exposure is used, such as traffic flow per hour in a particular place or the petrol consumption per year. These are used as indicators of air pollution exposure. These variables are also considered as quote unquote pressure indicators in the causal hierarchy. Other examples would be the use of pesticides in an area or the number of children living in houses painted with lead-containing paint. Now discussing biological monitoring. If the environmental factor under study is a chemical, the exposure level and dose can sometimes be estimated by measuring the concentration in body fluids or tissues. This is called biological monitoring. Blood and urine are most commonly used for biological monitoring. Other biological tissue that can be used include hair and nail clippings and feces. And you can see then what kind of information we can get from those sources. And it's interesting how epidemiologists will use the environment to understand exposure. So here's a study, not a journal I've ever considered submitting to, the Science of the Total Environment. Here is longitudinal monitoring of SARS-CoV-2 in wastewater using viral genetic markers and the estimation of unconfirmed COVID-19 cases. Monkeypox, remember how that was a really big thing last year? Monkeypox identified in the Bay Area wastewater. So they're able to get a sense of, because you can't monitor everybody, but they can get a sense of or estimate the incidence based upon presentation in the water. If you are interested in doing something involving biological data, again, you'd likely need to partner with somebody who has expertise in collecting and analyzing this type of data. Talked about this one previously. Epigenetic status of the human MMP11 gene promoter. It's altered in patellar tendinopathy. This is another type of example of where you might need to partner with somebody in order to look at this as a potential risk factor. Now, this doesn't really have anything to do with occupational or environmental disease, but it illustrates that by working in teams, we can potentially do great things. A geneticist may not understand who experiences patellar tendinopathy, but a physical therapist, an athletic trainer would. And so it's the combining of those skills to potentially come up with something very impactful from an epidemiologic perspective. Same principle applies here. Somebody that understands epidemiology and understands viruses is going to have an appreciation for that, looking at monkeypox in the wastewater. Where this becomes important for public health officials and for physicians is then to partner with those individuals, again, to research it, because those physicians are going to be the ones that are concerned with, and those public health officials are going to be concerned with then going to the populations who are at greatest risk and identifying them and getting out the message that this disease is out there, it's spreading, and reporting how the disease is spread so that way people can do preventative things to reduce the spread of the disease. And also, too, it helps public health officials to understand how much in resources they might need for treatment purposes. Right? If we're looking at wastewater in an area, especially early on in the pandemic, did we need to see that there might be an increasing spike then in the need for ventilators in an area for those who would be admitted into a hospital? So you can kind of see how people working together can look to potentially predict how incidence is going to increase and how that might put a strain upon the healthcare system. In epi-studies of cancer caused by environmental or occupational factors, another way of presenting group dose is sometimes used. This is the dose commitment or population dose. It's calculated as the sum of individual doses. It's based on fundamental assumption that there is no threshold individual dose below which the cancer risk is zero, and the cancer risk increases linearly with dose. For many environmental factors, effects range from subtle physiological or biochemical changes to severe illness or death. Usually, the higher the dose, the more severe or intense the effect. This relationship between dose and severity of effect in the individual is called the dose-effect relationship. So dose-effect relationship is illustrated here in figure 9.5. What is shown here is the average dose at which an effect occurs. At a low carbon monoxide dose, as measured by the carboxyl hemoglobin in blood, a slight headache would be the only effect. But as the dose increases, the effects of carbon monoxide become more severe, as this figure illustrates. Now, not all individuals, and here's the key point looking at this dose-effect relationship and understanding that this is a relationship that is kind of estimating things. Not all individuals react in the same way to the environmental exposure, so that dose effect relationship for the individual differs then from the group level. Now, looking at dose effect relationships, this relationship provides valuable information for the planning in epidemiologic studies. Some effects may be easier to measure than others, and some may be of particular significance for public health. Measurements of changes in biomarkers, such as blood or urine, may be used to study early subtle effects as well as the exposure. Response, the dose-response relationship, response is defined in EPI as the proportion of an exposed group that develops a specific effect. The shape of the relationship looks like an S. At low doses, almost nobody suffers the effect. At high levels, everyone does. So, here's an example. Figure 9.6, pedestrian fatality risk as a function of the impact of speed of the car. So, very low speed, we get a very low probability of death occurring. But as that speed increases, this is that dose-response relationship, we get an increase in the probability of death occurring to a point where then at certain speeds, everyone dies. So I just kind of talked about this already with traffic crash injuries. If we go back to the last slide here, we see again that lower speed and the possibility of death in a pedestrian. But if we take a look at faster speeds, somebody's going to die or there's a greater probability of death. Let's talk about traffic crash injuries in relation to individuals in the car. There's that same type of relationship where injuries may be less severe if you're going at a slower speed, but obviously if you are going at a faster speed, they can be more severe if somebody's not using a speed or a seatbelt. So what can be preventative? What can help? Well, looking at preventative approaches, speed reduction. So areas where there's more traffic crashes, lower the speed in that area or those areas in order to give people more time to react. Also, the use of seatbelts being a major public health event that has saved lives. And so here is the relationship between driving speed, seatbelt use, and frequency of injury in drivers involved in collisions. And so what we see here is a difference in the frequency of injury based upon speed and the use of seatbelts, and where non-fatal injuries would occur if somebody is belted versus unbelted. Workplace injuries, different types of examples here that can be explored is chemical exposure and agricultural workers. Chemical exposure definitely increases the risk of certain forms of injury to an individual. And if you can decrease that chemical exposure, you may help to reduce the poisoning or other diseases that come along with that. And so understanding that there's that relationship, what can you do to decrease exposure, or what kind of safety measures can you put in place? Same thing with back pain and construction work. So we appreciate that with manually intensive types of positions that back pain can occur. Well, are there ways to reduce back pain through different preventative measures? It's probably not the first thing that somebody does that causes the back pain, but that accumulated exposure over time. Violence is another public health problem that has been highlighted through epidemiological analysis during recent years. In some high-income countries, homicides are a major cause of death among young males and can be even worse in some low and middle-income countries. Suicide, another important cause of death. The environmental factors causing suicidal intent are primarily social or economic, but completed suicides are also dependent on access to suicidal methods, which can be seen as an environmental factor. All right, so again, some interesting stuff, maybe stuff that's not relevant to what you're interested in doing, but that's okay. For this forum this week, you're going to propose a research study and study design to assess risk in an environmental and occupational setting. including the following: population and setting, length of the study, and exposures. Um, I've got an example I think coming up later on in this, and so that's what it says there. The screencast for this week will illustrate an example for how to complete the form. And that discussion is worth 3 points. There's also a homework assignment that is due this week that is somewhere around the same topic. Here's the form example, prospective cohort study. I might do population and setting male migrant farm workers, and the setting is vineyards in Washington and Yamhill counties. The length of the study would be 1 season. I collect measures associated with the spine. So if back pain is my concern, what I want to look at, maybe different tests for spine strength, maybe doing a handheld dynamometer to look at glute strength, and then maybe a visual observation of lifting mechanics or some sort of tool, if there's any such tool out there that's an objective measure of how somebody lifts. Spine range of motion, maybe I would use inclinometers. And then exposures, I would collect daily work exposures, collect information regarding what jobs they're doing during different times of the year to see if there is correlation there between injury and what they're doing. Homework, 10 points. You're going to provide one example of a prospective cohort study, provide one example of a retrospective cohort study, and provide one example of a case control study.